Hello, it's me, and I'd like to go back into the collection to talk about different types of forms of puzzles that we have. So you all know about the face turners, but you've also got the corner turners. Corner turners are those that don't turn at the face, but they turn at the corner. And there's actually two types of corner turners that we're going to kind of get into and delve a little further into. You've got the Dinos and you've got the Skewbs. They're both corner turners. The basic difference is that the basic structure of a Dino is that it turns on the corners, but there's no actual corner piece. What we have is we have a series of edges. It's really all edges. Whereas this is all corners that turn on the face with no centers or edges, and this is all corners. This is a corner turner that's all edges over here. Basically, it's a non-shapeshifter because with every turn that you do that will lead to another turn, you put it into a slot that is similarly an edge. So a Dino is a corner turning puzzle that has no corners but edges and orbits about a corner axis that has a corner that doesn't actually exist. So what then is a Skewb? Well, a Skewb is also a corner turner, but it's a corner turner that contains corners. And generally speaking, it has corners and centers. The way this works is because it's a corner turner and has a corner, it turns about the axis of a corner that stays stationary, while all the corners that surround it move along with it. So basically, the way that it turns is that you have one center corner piece, basically, which is the axis of rotation, and it drags with it all of the corners that are attached to the center pieces that are dragged along with the corner with each turn. So that characteristic is that it sort of bisects deep into the puzzle, usually cuts it in half. So corner turning Dino, where you have edges only basically, and turns about the axis where all the edges turn with it, causing the classic Dino slice. And a Skewb is where you have corners and centers. Basically, as the base organization of the puzzle, you turn with the corner as its center axis and drag with it the corners that are attached to the centers that also turn with the puzzle. So that, in essence, is what a Skewb is. The solve strategy of the Dino and the Skewb is fairly straightforward in that there's not too much other moves that you can do except down, down, up variations of that. In this case, they're just deeper slice, down, down, and ups. And I've gone through tutorials of these things where it shows how you can navigate these center pieces and navigate these corner pieces. Now, just by comparison, let's look at the master versions of these things. So what then would be a master Dino? Well, a master Dino would have a form that looks something like this. What you see here are Dino slices. If this were a true master Dino, these would turn about its axis. These would be the edges only area, just like this. So this would turn just like this turns. But because you have another layer, you're also going to be able to turn this layer over here. So this is another Dino move. So you've got a Dino axis over here and a Dino axis over here. And notice these act as edges. These whole things together can make up can be thought of collectively as corner pieces, but this is just the edge with that. So once again, you're turning about the axis of edges. You're turning about the axis where there's like a hidden corner axis that's here, and you've got edges that are turning about that. If you look at the master version of the Skewb, well, you've got the master Skewb, and you can see that these have corners over here. You turn about the axis of the corner, and you drag these corners along with it. So because you drag these corners along with this corner, then it has the characteristics of a Skewb. The difference, of course, is you have this extra middle piece in the center there too. Now, for this puzzle over here, it acts as a master Dino because it drags along these edges with it too. If this were to act like a Skewb, it would take all of these corners as a unit and move along with that. This actually is a Dino Skewb, where it's a combination of Dino cuts and Skewb cuts. But actually a master Dino would look exactly like this. This doesn't turn over here, but in a master Dino, this would turn. So that's the basic difference between a Skewb and a Dino. For a Skewb, you have to take the corners with you, and it bisects down the center. With the Dino, it's just the edge portion that turns along with the edges that form a center axis. That's basically a corner. So those are the basic forms. Now, what exactly is meant by this? Now, just to kind of demonstrate these things, which is kind of cool, if you were to look at the Master Skewb, and the Dino Skewb, they have kind of a similar look to it, but you can see that the axis of rotation of these middle segments are different. This is just below the area of a Skewb with these corners acting as one. This includes the the corner areas. If you combine these together to act as a corner, it slices down here. And the solve strategy is very different. So we can move this back over here and move this back over here. More on those later. So let's hone in on some of the strategies specifically with these corner turners. The Dinos, which are edges only, and the Skewbs, which are corners and centers. Again, we have corners and we have centers. We do have edges over here that make up this other layer. As a Skewb, master Dino, really just edges that are here. Although collectively, if you look at these all as collective corners, then you can move it like a Skewb. Okay, so the strategies here are basically down, down, up, up. So let's focus on the Dinos a little bit. Now, I'm going to revisit a couple old puzzles that might surprise you that act like Dinos, and actually a new puzzle that you might not have seen. The strategy of a Dino is actually a very simple puzzle, and I don't want to spend too much time on it because, well, I've done tutorials on this before, but this down, down, up, up scheme that happens with this, when looking at the solve of a Dino puzzle, basically with the edges, we place the edges by doing these Dino cuts that each go about 120 degrees. So two greens are over here. It doesn't really matter what these colors are over here. And we can easily just kind of place this by positioning and intuition. This needs to come up here. So we'll bat these two out of the way, put this up here, and look at that. Does it matter what these are? Actually, no. I can even flip-flop these two and have a solve confirmation that has these flip-flopped, and it really doesn't matter for this particular puzzle. Turning it upside down, we place these quite easily, red and yellow. Well, that's going to come over here. Look how simple that is. Ultimately, what it comes down to, after you've filled these layers in, these bottom layers are already filled in with this bottom layer over here. These are simply placed by doing Dino cuts over here. Inevitably, with the last layer, you're going to have two edges that are oriented correct. One of these edges are going to be in the right place. The other one is not. And the solution from here is pretty simple. You grab the Dino slice that contains the two edge pieces that are not rotated correctly. You keep the one that's rotated correctly and placed right at the back, and you just go down, down, up, up. And it's that simple. What's also interesting is that because there's no centerpiece here, I can actually flip-flop these two. So let's say I decide to put the red one over here and the yellow one over here. I'll just take this out and cleanly place this green one up here. Actually, yeah, move this out of the way, move this up here, move this down. So I just flip-flop these two, keeping these guys the same. Turn this upside down, and now I can just redo this. So this comes over here, yellow and white, without really spending too much time thinking about it. Place this in intuitively. Blue, turn, 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 and turn. Oh, white and red. Let's try that again. Turn, turn, turn. And so this is all fine, and it's going to be the same thing. These two blues are correct. This white is okay over here. So grab these two, down, down, up, up, and you see what appears to be a nicely solved Dino cube, except it's actually inverted. You wouldn't know that, or maybe you would, but these two have been inverted, and yet the solve of the puzzle is perfectly fine. Now, an obvious variation of the Dino puzzle would be this Rex cube. This is also a corner turner, much the same type of situation that this is. But in this case, you not only have edges, but you also caused a slice that's deeper, and you share that deep slice between two corner sides over here, which means you've kind of created freely movable corners, sort of, and you've got a center area over here. So we can look at these as edges and these, I suppose, as corners, and it causes a little bit of a challenge to put this in, but here's the point. With this puzzle, it had no centers, so I can invert things and not even care. But this, I can't do that. If I take this piece and put it here and this piece and put it here and invert that, I can go through the solve. I'll get my Dino back, but my centers will have parity because there's only one configuration that's going to go with the centers, as opposed to this. I mention that not because I want to go through another solve of this puzzle, which if you'd like, I could do a reboot of that tutorial. I just point that out because as long as the Dino has no center, I can invert that. But if it does have a center that's been kind of created, then I can't invert that. So what else has the form of a Dino? Again, we're dealing with corner turners. Well, believe it or not, there's another example of a corner turner that has almost exactly the same form as the Dino cube. So which one am I talking about? The puzzle that I'm referring to that has Dino features to it, that is pretty much a Dino puzzle and can be reduced as such, is this guy. This is the Dayan Gem 3. Now, the difference between this and the previous Dayan Gems is that they are, well, they're very different puzzles. They're edge turners, which means they jumble. This one is a pure face turner. It's got these star faces that turns over here, and it's also got these little square faces that it turns over here as well. A nice little challenge, a nice little solve, and I did have a tutorial on that, introducing some new algorithms to solve this. But here's an alternative way of looking at this. If I look at this, like a Dino, you'll find that it actually really is a Dino. Imagine taking a Dino puzzle, cutting it down here, then creating a flat surface, sort of creating a center. I'd end up with something like this. So if I were to, say, look at this as a structure similar to a Dino cube, if we correlate these with each other, and we call this an edge, this an edge, this an edge, and this an edge, then that means these whole areas here and here are like corners. So if I turn this corner up over here, that's equivalent to this over here. So this is actually like a Dino corner. This is correlated with this. So if I were to bring this back down here and maybe turn this up, that means bringing this back down and turn this up, then this is correlated as a Dino corner. So basically, these are like Dino cubes with the difference that we actually have centers over here. The analogy is continues with the fact that this and this pair of colors here represents these over here. So these two pieces here are equivalent to this whole edge piece over here if this were to be reduced down. This edge piece here is equivalent to this whole edge piece here, and this back edge piece over here is correlated with this edge piece. So when I turn this, I've got these edge pieces that are turning. So too with this corner, if I turn this here, I've got 1, 2, 3 edge pieces that are turning. In addition to that, I've got these centers. These edges are reduced along, these center edges are reduced along with this, and then you have these parts which are part of the, I guess, center. So these triangles are part of this new center that's born out, and these edge pieces here are parts of the overall Dino edge pieces. So you've got the Dino edge pieces here consisting of these two corner pieces and this bi-colored edge piece, and then you've got the center piece, which is this big center here with these center triangles that are just unicolored. So the point with that is that this can be solved almost exactly like a Dino. The only difference is that as we extended this out, you can actually turn the face. So it's like you have a Dino cube that can also turn on the face. It's like having a 2x2 Dino cube, although not exactly, because this face, when I turn it, doesn't really affect this face. So what this means is I could take this puzzle and reduce the edges and solve it exactly like a Dino. The only difference is that I've got center pieces to guide where to go. So what I'm going to do, just to demonstrate that, is an alternative solve of the Dayan Gem 3 using it as a reduced, basically reducing it to a Dino and solving it as a Dino with these as the faces, these as the edges, and these as the centers. So I'm just going to go ahead and do what I would call the Dino moves. So any moves that have to do with this surface here, this face, I'm going to call corners. These are the corners basically, and what I'm doing is I'm just doing Dino moves right now. Now I'm going to do 2x2 moves by moving this over here. So I'm going to continue the process of scrambling this and then kind of quickly go through an alternative solve of this, where instead of doing layer by layer like I did the last time, I'm going to go ahead and do it by reduction to a dino and solve it as a dino. This is going to become important for some future puzzles to demonstrate that borrow upon the dino concept. So abracadabra. Okay, so it's scrambled. So the first step that I would do in the reductive part of this strategy is, let's go ahead and reduce all the centers. To reduce all the centers mean it's this center 1, 2, 3, 4, 5, 6 hexagonal area with these triangles, not these, but these triangles over here. So starting off with the green one, we're going to find the little green triangles here. Now, these triangles actually kind of represent a piece that fits in between these spaces over here. So it's a centerpiece with these little triangles that fit in between over here. So if I were to look for the green ones, here's a green one here, just move them into place, and then I do a face turn over here. So dino turns to move it into place and face turns to move it in. So example of another one over here. So we're going to do dino turns, face turns, dino turns, and this is already in. So move this over here and dino turn to bring this up. And now same thing here. We'll do a face turn, dino turn, and put this in position and move this in. So this represents one completed reduced center. Ignore these, but you can imagine the triangle over here. So now I'm going to put these in. These triangles are going to be facing upside down for here, here, and here. So for the yellow, we're going to move these in from here. So here's this over here. So I'm just going to move this, do a dino turn and then a face turn. Once I have that there, just bump it out of the way. Another one. Let's see, this one over here, turn this over here, turn it in, and then move this up. So now I just need to put another one down here. We've got one here. Now, the good thing about this is when I do dino turns, it does not affect any of these, which are just moved by face turns. So dino turns I can move like crazy and not really care. Turn this over here, turn this here, and now I can turn this in. So now this upside down triangle is in, the center's in, move it over here, and put these in. So here's a red one, bring this in here, and move it up. We've got this over here, I'm just going to move it down, do a face turn to bring it in. So these two are in, bump it out of the way. Now I'm going to put another red one in here, as soon as I find one. So this is more, again, just positioning. There's this, here's a red over here, do some face turns and dino turns to move it in. And turn. All right, so this is in. Now the pink one. Here's a pink here, turn it in, bump it out of the way. Here's one here too, turn it down, turn it in, bump it out of the way. There's this, turn it down, turn it in, and now we've got this. So this, this, and this are done. Now we move down a layer for this. This triangle is going to be right side up. This silver one's already here. I'll just move this out of the way. Now here I have to coordinate these centers with these centers over here. So how am I going to move this into here without destroying this? Well, we'll do a dino turn to move it out of the way. Now I can coordinate it with this side over here. So I go on 2, bring it in, putting these in the proper orientation, and 1, 2. Another silver one right over here. So I've got to coordinate it with the red. So I'll go 1, 2, bring it up, 1, 2, in and in. We keep going. The white one. This is already in. We should have some more here somewhere. Here's a white one here. Move this over here. I have to correlate it with this over here. So we go 1, 2, turn it in. And actually this is already in, so I'm just going to move this down and go 1, 2. So this is in and this is in. Now we've got this one. We're down to the last 2 centers. Last 2 centers. So here's the blue one. This stays here. here's a gray one over here, so, or an orange one over here. So this one will be move this in, move this up here to replace it with this. And last but not least, these two have to swap. So I'm going to move this over here, take this, move it into this place, bring this down, and move it in. So just by positioning, I'm able to get these triangular centers. Once I've done that, once I've reduced the centers, I'm now going to reduce the edges. These edges are actually going to become reduced edges that are going to be my dino edges. The way that I do this is not at all unlike reducing the edges of 4x4s or 5x5s. You just bring it in and then, well, I'll show you. Red and silver, let's focus on that. Here's a red and silver here. I can move this over here so that this is in. What I'm now going to do, so basically I used a face move so that I can move it into here. Now I'm going to replace it with something up here. So move it up, turn this in, move it down, and bring this back, exactly like I did with the large cubes. So we put the other red and silver. We got to find it first, and it's over here. This can wind into here, find something up here to replace it with, and there's plenty to choose from. 1, 2, puts this in here, move it up here, replace it with this, bring it down, and go 1, 2. It's not going to destroy any of my centers, and now I have my first reduced edge. And now I just keep following suit. Now bear in mind, this is not an edge. This is a center, and these are corners of two overall edges that are being reduced. White and blue. Here's a white and blue over here. Position this so it can meet this over here. 1, 2. You can see this is in. Turn, turn, turn. 1, 2. We're back to here. Find the other blue and white. Right over here. 1, 2. Now you can see that this is wrong because this white lines up but this blue doesn't. So it's a different white and blue that's supposed to come in. Maybe this one. So I'll move this into configuration. 1, 2. Nope, not that one either. So there's a bunch of puzzles that have blues and whites. So it would appear. How about this guy? Turn, doing dino moves just to put it in place. Okay, now that that's here, we go 1, 2. This one fits. Turn, 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 and 1, 2. Okay, so I'm going to keep doing this. I'm going to keep doing this up until the last two edges where things might get a little tricky. So 1, 2, this fits here, turn, 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 1, 2. Okay, so I have it down to the last two edges. What I want to do is I want to get them both to where I have at least two in that are matched up correctly. You can see this isn't matched up here. So what I'm going to do is take this and put it where it's supposed to be over here to start off with. So I need another one that's going to be kind of a sacrificial lamb. So I'm going to put this up here, move this in, bring this in instead, and move this down. So this I'm sort of sacrificing for the moment, and then bring that in. Now that I have that, I have to coordinate it to where the last two are only going to have two that are in. So let's see, I can take this, but if I move this in, I'm just going to repeat what's going to happen over here. So why don't I basically solve for this one and see where this one goes. Okay, so that's kind of what I want, because when I move this down, these two are going to be maintained. So I'm going to move this in to solve like this, move it out over here, turn, turn, and move it back. Okay, so basically all of these are reduced. Now it might not have turned out that simple, actually. What can happen is you're going to have a quasi-parity kind of a thing with this. So what can potentially happen is that you'll have two that are in that have to be swapped. And here's how something like that might occur. You may have a situation like this, where basically everything is in except for these two, and these two need to be swapped. So we're in a situation where you have to swap two corners. Well, no matter what the size of the puzzle, the shape of the puzzle, whether it's a gem or a cube, all twisty puzzles follow the, quote, law of cubes. One of which states that you can only do an even number swaps. So you can't just swap 2, because that's just one swap, that's an odd number. So the question is, before designing an algorithm, ask yourself the question, is it possible to do that? So looking around at the puzzle, you can't do this swap without swapping something else. And taking a look at these triangular portions of the center, you see that they're all equivalent to each other, which means it's very possible to swap these two in addition to swapping that. So we know that it's possible. We've actually already designed an algorithm that can cause that kind of a swap. The one that I showed during the first Dayan Gem 3 tutorial. So I can actually swap these two by using the same algorithm. It will cause rotation of these corners, but that can be placed with another algorithm to cause rotation here. So once you get this, if you have two that are out and you need to swap these two, put them on the same level and go ahead and do the swapping algorithm for these. In other words, put one to the right, front right, and back right. This is an R move, this is a U move, so it's R, U, RI, U, R, to U, RI, to U, and then turn it 90 degrees counterclockwise and reverse the algorithm. So it's RI, UI, R, UI, RI, to U, R. We'll just pop this back over here, and you see this is in, this is in, this is in, and this is in. So we have all of our edges reduced, but we took these centers out of kilter. What the next algorithm does is it keeps the one to the left the same and puts this to here, and this to here. So we just have to coordinate that. Well, it's going to be out of sync because you're going to end up with two that are in. So what I'm going to do is just go ahead and do the algorithm anywhere. It'll keep this here. This will come here and be in. This will come here and be in. This will come here and be out. So we'll seem to have a kind of a sticky situation, but here's how we're going to get out of that. We do the algorithm to rotate those around. R, U, RI, U, R, to U, RI, to U. Then we do it again. R, U, RI, U, R, to U, RI, to U. So we have this in and we have this in. So what I'm going to do now is I'm going to put this over here, and I want to get things out of kilter. If I do the algorithm again, this will stay the same. This will move here, this will come here, and this will stay the same. But I don't want that to happen. So instead what I'm going to do is with this in front of me and this to the side, the two that are in, I'm going to rotate this by a half click over here. This will put this over here. This blue will be over here. So I'll just exchange these two, which means I'll be free to move this back up and kind of keep it out of sync, so to speak. So this is going to be the two swapping that I'm going to be doing. This will come over here, and this will ultimately end up over here, and that'll complete my cycle of appropriate swaps. So with this turned down here, I'm going to go, remember this blue will turn into another blue here. This will simply come over to here. R, U, RI, U, R, to U, RI, to U, R, U, RI, U, R, to U, RI, to U. Okay, with that done, I now switch this back. So now I just have this in, and the rest of these can be cycled around. Two more clicks of this algorithm will put this to here, and this to here. So this will come here, this will come here, and this will come here. U. And my goodness, it worked. So all these are reduced and all the centers are reduced also. So basically, I have now reduced this to a Dino cube. The only difference is I have to be mindful of the centers when I didn't have to be mindful over here. So now that I've reduced this, I'm going to solve it exactly like a Dino. So let's pick a side. We've got this green one here. This is matched up to the right center here, but let's match this to the correct purple center over here. This green you can see is not the correct one because this green side, so I'm basically solving it like this. I've got this in over here, and now I'm looking for this portion over here, but it has to be the green and orange. So here's the green and orange, and I'm just going to move this here, turn it over here, and just match it in over here and turn it here. Okay, so this is okay here. Now it's just a matter of putting the rest of the greens in. This is here, and this will automatically come in where it needs to be, I think. Okay, this guy comes here and here. I've got to move this up to here, so let's bat this out of the way. This is pure Dino Cube strategy. So this is in, this first side is in, and all these edges are where they need to be also. These corners, I should say. So I'm looking at all these as corner turns now. So now I'm going to put these in. Just like I put the bottom here first, then I moved here and I put these all in over here. What's the same thing here? I've got this in, now I'm going to move. These are already going to automatically be solved, just like these bottom ones here are solved. These guys here are likened onto these guys here. So I'm just going to put these in. This one is already in. Orange, I have to put the other orange here. So I'm just going to bear in mind that I'm doing Dino strategies. Where's the other orange? The other orange is way over here. So I'm just going to wind this around and simply place it. So that's okay here. Move over to here. This is in. I got to put the red one in here. It's not hard to find. Turn and turn. So this is good. I've got to get this white one back here. Bang. So this is good. So all these are in. So now it becomes easy. I just simply look at the last layer and I know 2 are going to be in. Of those are going to be rotated correctly. Of those 2, 1 is going to be correctly oriented with a proper center. So I'm just going to hold it over here, grab this portion here just like I did when I was grabbing it over here. And then using the Dino strategies, simply go down, down, up, up, and it's solved. So basically the majority of this was reducing this to a Dino. Instead of doing it layer by layer like I did last time, I simply reduced the centers, then I reduced the edges, used that same algorithm to make sure I did swapping of the last 2 corner pieces to put in as the edges, and then solve it like a Dino cube. So why did I do it this way? Why did I take the time to do this? Well, there's a number of other puzzles that I'm going to be introducing. Other corner turners, or things that look like corner turners, that I think you'd be interested in. Well, this isn't exactly like a Dino because it actually turns on the face. This is like having something that's a corner turner and a face turner. But this isn't exactly like a face turner because if it was like a face turner, I would turn this and it would affect the faces on the other side. Just like if you looked at a 2x2 to turn this face means I'm going to be affecting these faces here. But this doesn't really do that. It's like the faces have been pulled out. Does there exist an actual Dino 2x2? This is like a quasi-Dino 2x2 where you had 2x2 moves, sort of, but didn't affect the edges, the corners of the other 2x2 faces as it would a normal 2x2. But is there an actual puzzle that's sort of like this, that's a corner turner and is a combination corner turner face turner? This is actually a combination corner turner and face turner. But is there one that takes the form of a 2x2, which is a combination of a face turning 2x2 and a corner turning 2x2? And the answer is yes, there is. Put them both together and you get this handsome little thing over here. Well, let's move this in just to demonstrate that. This is what's called a Super X. You've got an X over here. You can see that it has the form of the edges of a Dino cube, and indeed, it actually makes Dino turns, just like it would over here. But in addition to that, you've got cuts of a 2x2, and it actually scrambles or moves as a 2x2 as well. Turning here, turning here. So this is a Super X. This is actually what this tried to be. A true hybrid puzzle. A hybrid between a Dino puzzle, which is a pure corner turner, and a 2x2, which is a pure face turner. What we're going to look at next is how to solve this, and I'll tell you, you solve it very differently from this. This was simply reducing this to a Dino and solving it as a Dino. This, well, you don't reduce it that way. You kind of reduce it to the corners of a 2x2 using Dino moves and then solve it as a 2x2. So given enough time, I think what I'm going to do is demonstrate my solve strategy of this very fascinating puzzle, which is the Super X. Stay tuned. Thanks for watching.